Good morning, everyone. So myself, Priyadharshini, working as assistant professor in the Deputy Department of R&D Engineering College. Today, I am going to discuss a topic from the subject of Principles of Electrical Engineering. The topic is about KVL and KCL. So what is KVL and KCL? Kirchhoff laws. The Kirchhoff's voltage law and the Kirchhoff's current law. So what is Kirchhoff's current law? Kirchhoff's current law states that the algebraic sum of the current at a node is equal to zero, or sum of the current entering the node is equal to the sum of the current leaving the node. The same, that is, the explanation can be given or explained in a with the help of diagram. So in this diagram, totally the 7 currents are connected or related at a node. So from this, some currents are entering the node and some currents are leaving the node. According to the KCL, the sum of the current entering the node. So what are the currents entering the node is I1, I2, I4 and this I7. So all the 4 currents are entering the node and I3, I5 and I6 are leaving the node. So it can be related that I1 plus I2 plus I4 plus I7 is equal to I3 plus I5 plus I6. So here the same rule can be applied here also. So this is the diagram they have given. So IT is nothing but the total current. So total current, this is a node. Okay, so the A is a node. The total current is entering the node and it is split into the 3 currents. So entering the node is IT and splitting, that is leaving the node is I1, I2 plus I3. So total current IT is equal to I1 plus I2 plus I3. The next is mesh analysis. The mesh analysis apply to a mesh or a loop. So KVL, Kirchhoff's voltage law can be applied to that. And in a nodal analysis, it can be applied to the node. So Kirchhoff's current law will be applied. So here, what is the nodal analysis? Okay, so we are going to analyze the node, especially the KVL. KCL will be used in the nodal analysis. So here what they are saying is, so this is a circuit. I1 is the current entry. This is the current source has been connected to the circuit. R1, R2, R3 and R4 are the resistors connected to the network. So from here, I1 is the current entering and it has been splitted into I2 and I3. So I1 is equal to I2 plus I3. So how to write the I2 according to the Ohm's law? So I2 can be written as, so I2 is the current flowing through this. So it is connected between the node V1 and V2. So V1 minus V2 by R2. And similarly, what is I3? I3 is so flowing through this resistor R1. So V1 by R1. So here they have given a problem. Determine the voltages at each node for the circuit shown. So they are asking us to find out the voltage at each node of this network. So how many nodes are totally? So we are having the 2 nodes. So 2 nodes are nothing but the junction points. So here we are having the 2 nodes. So we have to find out the corresponding voltages. So next in this diagram, they have mentioned it clearly. So this is I1 and I2, V1 and V2. And the resistors are 3 ohms, 10 ohms, 5 ohms and 1 ohm. And here the current source has been used and here the voltage source has been used. So we are applying the Kirchhoff's current law at the node 1. So what is the Kirchhoff's current law says? The current towards the node is equal to the current away from the node. So the current towards the node is equal to 5 amps. So away from the node are the two currents are moving away from the node. One is I10, that is the current flowing through the 10 ohms. Another is the current flowing through the 3 ohms. So the current which is flowing through the 10 ohms is I is equal to V by R. So V is V1 by 10 and this is connected between V1 and V2. So V1 minus V2 by 3. So if I am applying that, so what is I10? V1 by 10 and this is V1 minus V2 by 3. So if I am simplifying this, if I am taking V1 as a common, 1 by 10 plus 1 by 3 will be coming out and here it is 1 by 3. So finally this is my equation. So the next is, if I am applying the Kirchhoff's current law at the node 2. So in the node 2, totally 3 resistors are connected and 1 voltage source has been connected. So I can use this voltage source as it is, or I want to convert the voltage source into the current source also, we can use it. But here I am using the voltage source as it is. So here the 3 branch currents are there. One is the current flowing through the 3 ohms, another one is the current flowing through the 1 ohms. Next the current is flowing through the 5 ohms resistor. So here this is 3 ohms means it is connected between V2 and V1. So V2 minus V1 by 3 and this is V2 by 5 and here it is between V2 and 10. So V2 minus 10 by 1. So finally this is the second equation. If we solve both the equations, the voltages are V1 and V2 is 19.85 volt and 10.9 volt. The next problem is determine the voltages at each node of the circuit shown. So totally how many nodes we have to fix it? That is for node 1, node 2 and node 3. So the resistance are 10 ohms, 3 ohms and 3 ohms, 2 ohms and 5 ohms and 1 ohms. The sources are 10 volt, 5 amps. So here they have connected like this. So if I am analyzing the each and every node at the node 1, similarly, so we are having 4 resistors and accordingly we are writing the equation V1 minus 10 by 10, V1 minus 2 by 3, V1 by 5 and V1 minus V2 by 3. If I am simplifying this equation, this is my final equation. And the next is at the node 3, at the node 2. So in the node 2, if we saw, similarly here also 3 resistors are connected and 1 current source has been connected. So it is also towards the node. So 5 amps and remaining and all as it is. We have to use the Ohm's law and write the equation. And final equation is this. And similarly, this is my last equation. If we analyze all the three things, our voltages are V1, V2 and V3 by applying the Cramer's rule. Find the del and get the V1 and V2, V3. So here the question is find the nodal voltages in A and B. So similarly, we have to solve all the things VA and VB. So here the 2 volt and 5 volt they have connected. So accordingly, we have to write the equation. So what are the equations? So at the node A, so 3 resistors are connected. So if I solve it according to the KCL, my equation is this. And similarly at node B, if I am applying the KCL rule, the equation is this. Whenever we are solving both the things, we will be getting VA and VB. Using nodal analysis to find the power dissipated in the 6 ohms resistor of the circuit shown. So in this circuit shown, we have to find out what is the power dissipated in the resistor 6 ohms. So for this, we have to find out the current which is flowing through the 6 ohms. So especially they have said use the nodal analysis and they have given that these are the nodes. So apply the KCL and get the current which is flowing through the 6 ohms resistor. So if I am solving this at the node 1, V1 minus 20 by 3, V1 minus V2 by 1 and V1 minus V3 by 2. And this is my final equation is 6.67. This is equator to 6.67. And the next equation at the node 2. So this is the next second equation. And the last equation is at the node 3. In the node 3, there are 3 resistors are connected. It is between V3, V1, V3, V2 and V3 and V3 and V2. Okay, so if I am solving it, the final answer is minus 0.5 V1 minus 0.167 V2 and plus 0.867 V3. Finally, if I am solving all these things, the answer is V1, V2 and V3. The current in the 6 ohms resistor is V minus 0.74 and the power dissipated is I square R. By using this principle, we can able to obtain this. Okay, so in this video, we have solved the problems using KCL at in the nodal analysis. So thank you.